We're going to be taking a look at 7.5, solving quadratic equations by factoring in this video. The objective is fairly straightforward. We want to make sure that you understand the necessary skills and methods involved in factoring a quadratic equation. The vocabulary centers around the same theme. We want to make sure that you understand clearly what a factor is or factors and what is meant by factoring. So in this particular section, we've been exploring how to find the x-intercepts of a quadratic function. We learned a little bit about the difference between a quadratic function versus a quadratic equation, a function being equal to f of x or y, and an equation being equal to 0. When I solve a quadratic function, as we see in this case, I'm looking for the x-intercepts, or the zeros of the graph. And when I solve a quadratic equation, so when it's equal to 0, we find the roots of the equation. We've used a couple of different methods with graphing to start with. And so we're looking for various ways that we can actually figure out where does this graph cross that x-axis. Now the problem with graphing is, though, that you don't always have a graphing calculator handy, and you're not always going to be allowed to use one in an assessment. We also learned that when a quadratic equation is written in the factored form, so when it's been broken down into the tiny pieces that multiply back to equal the original, we can easily find the x-intercepts, or the zeros, and in this case, the x-intercepts would be x equal to r and x equal to s. Now remember, if I do find what x equals, I have found the intercepts, the x-intercepts. So the question is then, how do we actually solve this algebraically? Well, the vertex form is fairly easy. Remember, you have the standard form and the vertex form. Let's take a look at a question where we're being asked to solve for x. If it's in the vertex form, if we're careful, we actually should be able to get to our answer straight away. So let's see what we have here. We're going to move the 9 to the other side. And then we need to get rid of this square that's here. So we're going to take the square root of both sides. Square root of 9 is plus and minus 3. And the square root of x minus 1 squared is just x minus 1. And then we can take our 1 and move it to the other side. So when we look at it, we have two possible answers, 1 plus 3 and 1 minus 3. That's where we get our answers of 4 or negative 2. The real challenge, though, is finding the x-intercepts when the equation is in the standard form. And so we're going to take a look at that in the next little while. This all boils down to factoring. So many of you have had a good background in factoring, and really what we're doing right now is just reviewing, making sure that you're perfectly comfortable with the process of factoring. So how do we factor a quadratic equation in standard form? There are a number of skills we need to review, and the first one we're going to look at is something called the greatest common factors. Being able to look at a quadratic equation and sort out whether or not it has a common factor, and then pulling that out of the equation. So let's take a look at it. Here we have 5x squared minus 45x equal to 0. So the first thing I notice is that 5 is something you share in common, and an x. And so I'm going to pull out 5x. And what I'm doing is I'm dividing 5x out of each one of these terms. That leaves me with an x to start with minus 9. Now it's set up in the place that now I can solve what the x's are. I know that either this 5x is equal to 0 or x minus 9 is equal to 0. And in that case, x is equal to 9. And in this one, x is equal to 0. So we have two possible x-intercepts, 0 and 9, for this quadratic equation. The next one, we're also going to be asked to look for the greatest common factor. Now, if you look at this and think, I don't like working with decimals, don't fear, you can actually get rid of them. What we're going to do is simply take those decimals and multiply by 100. And if we do that, that gets rid of those two places of decimals here and the one place here. But it changes my numbers, of course, to 25x squared plus 150x equal to 0. Notice that we've multiplied by 100 and on the other side as well, but it's still just 0. Now I can see that I have 25x that I can factor out, leaving me with x plus 6. So this one could be 0 or this one. So I get that x is a 0 or x is negative 6. The next thing I'd like to look at is something that we call factoring by grouping. And I understand from working with all of you today that you called it also decomposition. And so this may be more familiar to you by that name. Factoring by grouping is something that we can use when we've been given four terms like this. And what we aim to do is we take the first two and sort out what they share in common, and then the second two. So let's take a look at what that looks like. So I pull out a common factor here of just x. It leaves me with 4x minus 5. And for the next part, I'm going to take out positive 3, which gives me 4x minus 5. Now, both of these guys are the same. So I have a common factor of 4x minus 5, and my leftovers are x plus 3. And since these are both equal to 0, I can solve for both of those, giving me x equal to negative 3 and x equal to 5 over 4. Here's another one. And again, as we always do with these videos, I'd encourage you to pause and try this one again on your own. So we're going to do the same thing. We're going to find a common factor of the first two terms and then of the second two terms. Let's see what it looks like. So we pull out x for the first two. That leaves you with x minus 4. We pull out negative 7, and that leaves you with x, please notice, minus 4. And what's happening here is it's 28 divided by negative 7, which is negative 4. Now, these two we share in common, so we're going to pull this one and this one away, and we're going to say our factors now are x minus 4, and the leftovers were x minus 7. And once again, we can solve for those two values that equal 0, and we have x is equal to 4 and x is equal to 7. Okay, that prepares us with enough for factoring a trinomial. And a trinomial, of course, is a three-termed polynomial. And of course, you guys have seen this before, so we're going to be following some process to try and get through this. And so basically, what we're going to do is use a bit of a strategy, a strategic move, to take this middle term and break it into two so that we can factor by grouping. Can't just do it though with any combination of numbers. We do have to use a specific one. And so in order to find that specific one, what we do is we take the a and the c values and we multiply them together. And we look at the b value. And what we say is we're looking for two numbers that multiply to be 2 times 6, which is 12, and add to be negative 7. Usually I write those down over on the side so I have something to remember it by. And I realize once I think about it that negative 3 and negative 4 would satisfy these requirements. So I'm going to take negative 3 and negative 4 and rewrite the middle term. And once I do, it's set up now that I can factor by grouping. I pull an x out of these two, leaving me with 2x minus 3. And I pull a negative 2 out of these two, leaving me with 2x minus 3. So again, I have a common factor, 2x minus 3, and the leftovers are x minus 2. And I use those two equations that I have, and I solve for x. X is 3 over 2, and x is 2. With this quadratic equation, as with all of them, and we probably should have just been on our toes watching for that, but we should always look for the greatest common factor first. And if you look straight across, you realize that you could pull a 2 out of all of these guys. And that leaves you, let me go back here, with x squared plus 7x plus 6. So I look for two numbers that multiply to be 1 times 6, so 6, and add to be 7. Those two numbers are 6 and 1, and I'll pull apart the middle term and then start to factor, pulling an x away for the first two and a 6 away from the others, so that I get a common factor of x plus 1 and leftovers of x plus 6. So I find that x is equal to negative 1 or negative 6. Now, one thing of note about this particular example, in this situation, once we pulled the 2 away, a that sits in front of x squared was equal to 1. And you will remember that when a is a 1, and you've found your numbers that you're going to use to split it up, you can actually go further than that. You can take those numbers, which were 1 and 6, and go directly to writing your factors, x plus 1 and x plus 6. It's a shortcut that you can definitely use once you feel confident about this decomposition method. The last thing I wanted to review was the difference of squares, being able to recognize it and know how to solve it. So if I have x squared minus 25, both of these are perfect squares. So in order to solve them using the difference of squares, I'm going to first of all look at what would happen if I solved it using decomposition. If I look at this guy, I realize that the b term, x, is missing, which means it's a 0. So when I think of a times c, I realize I'm looking for two numbers that multiply to be negative 25, but add to be a 0. That would be a 5 and a negative 5. Then I pull an x out of these guys and a negative 5 out of that one, giving me a common factor of x plus 5 and the leftovers of x minus 5. Now, when I examine what I have as my solution right here, I realize that my answer is simply the square root of this, x, and the square root of that, 5 and 5, with a positive and a negative sign. And that is how you solve the difference of squares very quickly. And right here, we know that x is equal to a negative 5 and a positive 5. Here's one more difference of squares for you to try. As soon as you realize it's the difference of squares, we look for the square root of this, square root of this, and add them and subtract them. So there you go, directly to your answers, giving you that x is equal to plus or minus 3 over 2. Now don't forget, in all this work and getting caught up in the algebra, don't ever forget what x actually equals. When I find it, what have I found? The x-intercepts. Now, there is one more style of question you could be given. It's this one where they're telling you, it's almost backwards. They're telling you now a quadratic function has x-intercepts of negative 5 and 6. So can you go now backwards and write what it looked like in its factored form for now? And so I look at these ones. I realize, well, if it had negative 5 as one of its x-intercepts, that came from x plus 5. That had 6, then it came from x minus 6. So this times this would equal my quadratic. And just to cover all my bases, I make sure that I just write an a in the beginning, knowing that there could be an a there, and I just don't see it with the factored version. And of course, if we were going to do anything else with this a, we'd need a lot more information before we could do that. But notice that I was asked to write a quadratic equation, so I've put a 0 in its spot rather than y, and I finished my question. Okay, there you go. That's a review of factoring. So please take a look at your homework and make sure you bring any questions you have to class.